Hello, class. Just wanted to touch bases with you to give you maybe a little help with the Moonlander milestone. Make sure everybody gets a good start to this. If you get a good solid start to the Moonlander project and getting the graphics work properly, it's going to help you out a lot with all the next assignments. They kind of build on the things that you learn from this assignment. So do all the extra things that it asks for this assignment, like creating the UML designs, planning things out really well. It will help you out in the long run with all the other assignments that are going to build on the things that you learn here and the code that you write for this assignment. So the milestone for this, after you've had a chance to get things set up for your environment and you've had a chance to look over the Moonlander project, the main thing you need to do for this week was to get a class made for the lander and try to get the lander to draw on the screen. Okay. So at a minimum, we need to create a class for lander. Our lander needs to contain at least a point object, and we need to fill in the draw method for the lander class to make a draw on the screen. And we will need to update the make file. Okay, so we have a few things to do here. So the first thing I'm going to do is I'm going to make the files for the lander class. I'm currently in the virtual machine, and I have the Moonlander files saved on my desktop of my virtual machine. I've given you the driver, the game object, ground object, point object, and a bunch of functions that will do the UI draw and the UI interact for the graphics part. So you get to create the lander class for this assignment. So I'm just using Emacs. Create the files however you'd like. I'm going to create lander.h is my first file that I will create. Okay, and I'll get in some standard stuff for this class. The if not defined, make sure to define it. And I'm going to, it says I have to have a point, so I'm going to include in quotes point.h. Okay, that file's already been written. And eventually I'll include the velocity, but we haven't created that yet. And then we just jump in and we create the class. It should be called lander, capitalized. Okay, we'll have a private and a public section. Okay, so I started drawing my UL design for my lander. The lander, if we look at the project, you see it's got the UL model kind of designed for you. So in order for your program to work with the files that I gave you, my files are expecting that you define all of these member functions. Okay, but you get to define the private variables that are going to allow you to make these functions happen, and any other functions you want to add to make your game work properly is fine. So let's see. I started drawing my UML, and I have my lander, and so I'm deciding to match up with those member functions. I'm going to need a variable called point. That's a point object. Eventually I'll need a velocity object, I'm going to need a Boolean to know if I'm alive, and a Boolean to know if I've landed, and I'm going to need an integer value to keep track of the fuel. So I'm going to add those to my private section. Now the point needs to be of type point. That's the point object that's included with these files. And I'll have one for alive. I'll put in the velocity one later. I'm not putting it in yet because I haven't created a velocity class, and so we'll put that in after I create the velocity class. Landed. There we go. Add an integer for fuel. And then in the public, I'm going to need all those functions that were defined. Let's see right here. I'm going to need all these member functions. I'll start with the constructor with some default initializations. I'll add in the velocity later. Landed. So it starts out alive, it starts out not landed, and the fuel, should probably make a variable, keep track of my default fuel amount to start the game. I'll make a constant variable, so we'll start it out at 500. So now if I ever change the default fuel, I'll just change it at the top there. Okay, so that's just my constructor. Okay, for the point, I need a getter and a setter for the point. Maybe I don't have a setter. I think point, I just need to be able to get it. So the point class will be of type point, or sorry, the get point function will be of type point. I'm not going to be changing the point, I just want to know the value of it, so it'll be constant. And I can do this in line. It's very simple, I'm just getting the value. Okay. And I'll probably have a get velocity one later. That'll be important for later. And I'll just leave a note to myself, even though I haven't implemented velocity yet. I know I'm going to need one. Just have it set up for later when I go to turn it on. Okay, I need a function to ask if I'm alive. See if I can see these functions over here. So I need is alive, is landed, get fuel, can thrust. I need all those. So is alive. Again, a constant. Making all these in line so far. Just return my Boolean variable that says true if it's alive, false if it's not. One for is landed, same thing. Access my my data members. through these getter and setter functions. So these two are Boolean. They return Boolean, so I'm just asking questions. Now I need a similar one for the fuel. Get the fuel. And I'm going to have a setter for landed, alive, and fuel. I'm going to need to be able to change those. And here's a situation where I need to use this pointer to be able to distinguish between the landed variable that belongs to the class and the landed variable that belongs to the function that is setting the variable for the class. So I'm setting the class's landed variable to the sent-in variable. We'll set alive. Same pattern for this. Just a semicolon. And one for fuel. This fuel equals fuel. So similar pattern for all three of those. And then my other functions I'll need to make sure to implement: apply gravity, apply thrust, right, left, bottom, and my advance and my draw. Let's make sure to get those. Okay. Now these I'm not doing inline. These are going to have some calculations and things we're going to do. You apply gravity, we apply a certain amount and then it'll do its thing. Doesn't return a value though. Another one, apply thrust, left, sure, it's super fun to watch me type. And we'll have thrust right and thrust bottom. We need the advance function and draw function. That one needs to be defined as a constant for when we draw. Oh, and just realizing I forgot the end of my if statement. To make sure that the lander is defined properly. Okay, so we have the header file for lander now. Okay, make sure I save that. And now we need to create a file to implement the lander. So a .cpp file for lander. To start the lander.cpp file, we'll just jump in and make sure we include the lander.h. We need the header file. And we're also going to be using the functions from UI draw to actually draw the lander. In the write-up there should be an explanation of the function for drawing. It's included in UI draw for drawing the lander. Okay, so let's see. Okay, let's implement apply gravity. Takes a float of a given amount. Okay, now this will be some fun stuff with velocity that you can work on later. You're basically going to create a velocity object and create it with a certain gravity, and then you're just going to add a little bit of gravity to it each time. So the velocity function, the velocity object is going to do most of the work for that. Okay, we need a apply thrust left function. Okay, and we're connecting it. We need to make sure to connect all these things to the lander object that we defined in the header. Okay. So this one we have the, if we look back at our, let's see, save that. If we look back at our .h file, let's see, we have a thrust variable, apply thrust. I'm going to have to think more about the apply thrust. Okay, I'll have to ask a question about if I can thrust, and then play some more with the velocity. So some more fun with the velocity. I'll probably have to make sure to consume some fuel. Alright, so there's more work to do on that function. How about apply thrust right? Alright, so I guess we're just kind of getting the skeletons done on these. Okay. I'm just kind of getting some functions going here. The thrusting is a piece that we'll have to think about later. We're going to be focusing on just drawing this, but I want to make sure to get these functions in place. Okay, and then for the fun one, okay, boy, here's where it gets fun. All right. We want to define the advance function. Okay, now we're dealing with a point. We have a point already. So we're going to take the point variable that belongs to the class, And that has a function called addX that takes a direction. So let's see. I'm going to have to figure out what that direction is. Okay, I'm just going to put a 1 in there for now. Just leave a note for myself. I'll get the direction from velocity. And same for y. So our ship's not going to be advancing yet. All right. And the most exciting of all, the draw function. We need this is for the win on the milestone. We want to be able to make this thing draw. So we defined it as constant. And we need to only draw it if it is alive. Now this was a function that was defined in line in the header. So if it is alive, we're going to call the draw lander function. Now we can call draw lander because we included the UI draw, and that is a function that is included inside there. Let's make sure we call it properly. UI draw, there's draw number, draw text, draw polygon, draw line. Okay, draw lander needs a point. Reference to a point. Okay. So we give it the point object from the class, and it should know where to draw that lander. Make sure to save that. All right, next step is we want to update the make file. We need to add references to the lander files that we just created. Okay, so in the a.out, after the point, we want to include lander.o, and we'll put in velocity.o later when we create those files. Also right here. Lander.o. A little bigger so we can see. Okay, make sure you always have tabs in your make files. Where else should we go? Add your additional rules here. Maybe that's it. Lander.o. All right, to define lander.o, we get lander.h, the header file, and lander.cpp, which relies on the point, and it'll also rely on velocity, but we'll put that in later. Make sure it's a tab. Compile it with G++. With the C flag. Okay, I think that's good. All right, let's look inside these files. Let's try running the make file, see what happens. Oh, we got some errors. So inside game.cpp, it's expecting some stuff that we haven't done. That velocity stuff, we might have to do more of a skeleton for that. Okay, and can thrust. All right, so we got to open that back up. Lander.h. Okay, it looks like we're going to have to define this. You may have to create a skeleton of the velocity files. Get velocity. We'll have to have a velocity variable and include velocity.h. I just have to remember to create that. And there was also can thrust. We need a function called can thrust. I'm just going to put it right here and leave draws the end. So can thrust, it's a question, so it's going to be a Boolean answer. Can thrust. Okay. Let's see, now we go to lander.cpp to implement that. Need to implement, I'm going to do the can thrust while it's on my mind. So bool returns a Boolean value, connect it to lander. The can thrust function will return true if, hey, now we can use those functions that we've defined. If it is alive and it is not landed. Is landed, not. Oops. And if the fuel is greater than 0. So 3 options for if you're able to thrust. You have to be alive, can't have landed yet, and the fuel needs to be greater than 0. And that should be a Boolean value that it returns. Good. And what other function was I forgetting? Apply thrust, save that. I'll give velocity, and I did that inline. Okay. Good. So now I'm just going to create a, let's see what happens when I say make again. Velocity.h, no such file or directory. Okay, so that's the next step, is I need to create that file to satisfy that. Okay, let's create velocity.h. I'll put in the regular stuff at the top. I'll define the class. It's called velocity. A private public section. This one's pretty easy. I know I need a X direction and a Y direction. default constructor to set the initial directions. Okay, let's save that. See if that's going to be enough to let our other stuff run properly. Okay. Make. Okay, we got some errors to look at. First one's fairly simple. It looks like I forgot a semicolon. No, that was in Lander. Oops. How to use Emacs. There we go. Ah, just forgot a semicolon. Okay, focusing in on this. All right, so now it's asking me about some more functions about the velocity, and I'm not ready to develop velocity yet, so I'm going to go into the game.cpp. And maybe find those lines, line 45. Is that right? 45. Maybe comment some of these things out. Just for now.
Major Richardson, if you are in the building, can you please come to the...
Sorry about the announcements. There. All right, let's see if that's even going to work. Hey. Okay, it still failed, but we didn't have a bunch of errors that time. Okay, it almost worked. I just have this weird error about lander.o-l galut. It doesn't make any sense. Let me check out the make file. And I see, open this up. Aha! I forgot to put a space right here, and so those two things got mushed together. The flags, you can see, were squished together like this. That's a strange error. Let's see if that helps. Save that. Hey, looks like it worked. We got a .o file. We have an A. Should make this bigger. There it is, a.out. So now, if you can get things to compile properly, you run the a.out file, and if the UI draw and stuff works properly, hey, it drew my lander. He's moving. I guess I hard-coded in the velocity and he's just going crazy like that, but that's the basics. If you can get that much done this week, then you're doing really well. Okay, and then it's just on to getting the finer details of how to make the lander thrust in the given directions and getting the velocity to work. So hopefully that helps you a little bit. And have a great week.